In this video, I am going to explain about inverse of non-singular matrix by Gauss Jordan method. Okay, so first let's see the concept behind this. What is non-singular matrix? Non-singular matrix is a matrix, square matrix, whose determinant is not equal to 0. See, for example, if they give some matrix A, this determinant should not be equal to 0. Then only we can say this matrix is non-singular matrix. I will show you an example for this also. So why we need non-singular matrix? To do inverse of Gauss Jordan, because the non-singular matrix is an invertible matrix and its inverse can be computed as it has a determinant value. Okay, we will see here how we will find determinant. So A matrix A, B, C, D, and the determinant of A is A into D minus B into C, which is not equal to 0, which should be not equal to 0. Then only we can find the inverse matrix. So this is for 2 by 2 matrix. Now we will see for 3 by 3 matrix determinant. How we will find determinant for this? Like this: A into B2, and this small matrix we need to take. When we are going to take A, we shouldn't take these things. We should take this matrix like this: A1, B2, C2, B3, C3 minus B1. When we are going to take this element, then we need to remove this and this. Now we will take A2, C2, A3, C3 like this. When you are going to take C1, then we shouldn't take these things. We need to take only these things like this. After taking this, these are all 2 by 2, then we can follow like this only: B2, C3 minus B3, C2 like this. A2, C3 minus A3, C2. Here also same: A2, B3, A3, B3 like this. This should not be equal to 0. Then only we can find inverse of matrix. So this is all about how to check the determinant. But how to find the inverse? So here it comes. We need to find inverse like this: A augmented with identity, and identity will be augmented with inverse of matrix. Don't confuse by looking into this. I will show you. So A is a matrix which they will give. Like for example, we can take it as 1, 2, 3, 4. So let's say they give this as an A matrix. Now we need to augment it with a matrix of identity matrix which of same order. That means this is the same order identity matrix, right? Now we need to make this matrix into a Gauss Jordan, or we can say we need to reduce it to an echelon form. Like that. Echelon form means what we will do? We will make this term as a 0, right? Then accordingly these things will change. Then the changes which are there in this matrix is called as inverse of matrix. Okay, we will see about an example, then you will understand clearly. Let's see an example. Find inverse of this matrix by Gauss Jordan method. Okay, now you will see here we need to take it as A of I, that means A augmented with identity. Then accordingly I will be augmented with A inverse. Now I have shown here. A will be written here. I is taken like this: 3 by 3 identity matrix. Now what we will do? We need to make this matrix as identity matrix. Okay, we took A augmented I. We need to convert into I augmented A inverse. So we only keep in mind that we only change A into I. Then automatically this I will change into A inverse. Then our result will be this matrix. Okay, let's see. We are taking A, we are just converting this into I. So how to make this I? Here 1 is there, here should become 1, here should become 1, remaining all should be zeros. Okay, now see first what I have done. R1 tends to R1 plus R2, nothing but row 1 plus row 2. So by this, see, by this we can make minus 2 as a 0. See, R1 element is 1 plus R2 is 0. 1 plus 0, 1, which needs to replace it in R2. 1 is replaced in R2. Now R1 plus R2 minus 2 plus 2, 0 should be replaced in R1. 0 is replaced in R. Next, minus 3 plus 0 becomes minus 3 only, minus 3 as it is, and R2, R3 will be same. So what operation we have done on this, which is also need to be done on this, the same operation. So here what happens, R1 plus R2, 1 plus 0, 1 only. Next, 0 plus 1, it should becomes 1, and 0 plus 0, 0, right? So we have just modified R1 by adding it with R2. Done. Now next what we will do, we will do another transformation, R1 plus R3. Why? We make minus 2 by using this, we made that into a 0. Now we need to make minus 3 into 0 by using this transformation. Okay, just we need to add this R1 with R3. R2 remains same. 1 plus 0, this will become 1 only. 0 plus 0, this will become 0 only. Minus 3 plus 3, this will become 0 now, right? So 1, 0, 0 will be the R1. Here you can see 1, 0, 0. But the R2, R3 will become same. Now the same transformation should be applied here also. See, 1 plus 0, 1 only. 1 plus 0, 1 only. 0 plus 1, this will become 1 here, right? So 1, 1, 1. And R2, R3 will be same. Okay. Now we need to do these 2 and these 3 to 1. Then only we can say it as an identity matrix, right? What is the identity matrix? The diagonal should be 1, 1, 1, 1. So 2 becomes 1, 3 becomes 1. Let's see how it should become 1. So if we divide 2 with 2, it will become 1. If we divide 3 with 3, it will become 3. Let's see how we will do. R2 is divided by 2. This whole R2, 0 by 2, 2 by 2, 0 by 2. Then 0 by 2 means 0, 0 by 2 means 0, and the middle 2 by 1, 2 by 2 will become 1. Here also 0 by 3 will become 0, 0 by 3 will become 0, 3 by 3 will become 1. So you can see here 1, 0, 0, 0, 1, 0, 0, 0, 1. This is an identity matrix. And what are the operations we have done for this also need to be done for this, right? So previously here 0, 1, 0 is there, R2. So we need to divide it with 2. 0 by 2, 1 by 2, 0 by 2. 0, 1 by 2, 0. Same follows for R3. So we got 1 by 3. So we got an identity matrix. So you can see here, first we took AI. A is a given quotient, I is an identity matrix. Now we reduced this matrix into this matrix, which is nothing but I, this is an I, and the other one is obviously A inverse. So we have reduced AI, this is the AI into I A inverse. Hence A inverse is this matrix. So this is the way we need to find inverse of matrix by Gauss Jordan method.